sequence AN satisfies the following conditions. The A condition is the absolute value of A1 is equal to 2. And the B condition says for all natural number n, abs of an plus 1 is equal to 2 times the abs of an. So if you look at these two conditions, they're giving the recurrence and the initial term for abs of an. So the initial term was 2, and in order to go to the next term, you need to multiply 2 for each terms, which means the absolute value of an itself is an geometric progression, okay? So it's like 2, 4, 8, 16, 32, keep going on. And the C condition is giving you, without the abs, just the an, you're adding up 1 to 10, and the sum of that should be negative 14. So satisfying all those conditions, you need to get what a1 plus a3 plus a5 plus a7 plus a9 is, okay? So you can just basically see that the C condition is giving you to the first term to the 10th term, and the problem is also asking you the sum of the odd terms, right? So we're only going to care to the first term to the 10th term, okay? So I'm going to write down abs of an first. So I'm just going to list this. So the first term was 2, the second term will be 4, third term will be 8, 16, 32, 64, 128, 256, 512, this is the 9th term, and finally the 10th term is 1024. So this is the absolute value of each term, the first term to the 10th term, okay? Then how's the an gonna look like? Yeah, I've just copied and pasted it. So we know the abs are 2, 4, 8, 16, like keep going on, right? These are the abs of it. But we don't know the signs of each terms, right? So for instance, the first term could be plus 2 or it could be the minus 2 because the absolute value is 2. For the second term, we don't know whether this is plus 4 or minus 4 because the absolute value is 4. For the third term, we don't know as well whether it's in plus 8 or minus 8. So now we have the goal of determining whether each term is positive or negative, okay? But how do we figure this out? Yep, only by using this condition C. Before we start this, I'll just explain two things and let's solve this directly. So I brought two things, right? First of all, this versus this. Which one is bigger? Normally you guys should think, maybe I think this is going to be big because you're adding all those end things up. And this is just a single term. But surprisingly, that's wrong. This is bigger. But we can actually calculate how much is it big. So you can basically use the geometric series formula, right? So summing up, I is 1 to n. It's going to be 2 power of I. So if you use the formula, it's going to be, the numerator is going to be 2, the first term, bracket on, 2 power of the numbers. There are n terms, right? And you need to put the minus 1. And it's going to be 2 minus 1, the ratio, minus 1. So if you calculate this, the denominator is just 1, so we don't really need to care about it. And if you just expand this, it's going to be, you need to add the exponents, right? 2 power of n plus 1 minus 2, right? Yeah, which means if you just compare these two, this is bigger than this, but how much? By 2, okay? So if you add 2 from here, it becomes this. So it's basically having a difference of 2. Alright, so I'm going to use this kind of concept onto the solution, so let's move on to the second one. So the second one is about the absolute value. Absolute value, you can actually divide it into two cases. When this an itself is purely a positive or equal to 0, just a 0, you can just actually take off this absolute value notation and it just becomes an itself. But when the an itself is a negative number, if you want to get rid of this notation, you need to put the minus symbol and you can take rid of this. And it becomes minus an because negative number, and if you put minus again, it becomes positive, okay? So those two are both positive, or this could be 0 in some cases, but anyway, you're making it positive generally. Okay, do you guys get it? So this is the really basic concept of this absolute value symbol. So guys, I have two questions for you. The first one is what is the difference between an and the absolute value of an? We can actually divide this into two cases. The first case is, let me write down here, when an is positive or equal to 0, okay? And the second case is going to be when an is negative. So yeah, by using this concept, there's no difference between these two. They're just equal when this actually satisfies, right? Because the abs of an is equal to an when this is a premise. So basically, I'm going to subtract the abs and the regular one. Okay, right? There are no difference. When it's negative, it's going to be a bit different because you're basically putting a negative sign on it. So, when I subtract absolute value of an and just the regular an, this will become minus an, and it becomes minus an as well, so which means it becomes negative 2an, alright? And be careful, since the premise was that an is a negative number, this is going to be a positive number, okay? So we normally define the difference as a positive number, right? So like for instance, what's the difference between 5 and 2? We don't say negative 3, we just say 3, right? So it's a positive number. So the difference should be the positive number. Alright, so there's no difference here, but there is a difference, but twice of it, okay? We can actually say like that. So if I just take an example again, it's like this. What's the difference between absolute value of 5 and just the 5? No difference, right? But take an example of absolute value of negative 3 and negative 3. What's the difference? This is 3 and this is negative 3, which means it has a difference of 6, right? Difference of 6. So let me write no difference as 0, okay? So there's a second question. What is the difference between the sum of the an and the sum of the absolute value of an? We can refer to these concepts, okay? So the positive are equal to 0, there's no difference. But if you sum the positives, there should be no difference as well, right? But for the second case, there is a difference of twice of the absolute value, which means if you sum all of the negative numbers, this sum will have a difference of twice the original absolute value sums, right? So for instance, let's say, like the problem, let's just say n is 1 to 10. I'm going to add up to 10th term. And let's just say it's an an. Actually, let's just downsize it. Let's just do up to 5, just to simplify it. So I'm going to say, so there are basically a1 plus a2 plus a3 plus a4 plus a5, right? And sum of an, but n is 1 to 5. Sorry, not the an, the absolute value of an. And I'm going to write on it. But for instance, let's say a1 is positive, a2 and the a4 was positive, and let's say a3 and a5 are negative, okay? But if you put the absolute values on, let's see what is different. We've just got the conclusion that the positive numbers, but let's just don't care about the zeros because there are no zeros on these problems, so let's just care about the positives. So positive don't have any difference, right? Which means it remains the same. A1 will be just A1, A2 will be just A2, and let's just put the positives together, so A4 will be just A4. But the negatives there are different. Since these are negatives, we need to put the minus sign on it. It becomes minus A3 and minus A5, alright? But let me just put on the brackets. Let's make this plus, and I'm going to put the brackets on. So basically what I did is I grouped the positives together, like this, and I grouped the negatives together. So now I'm going to find the difference, which means I'm going to subtract this to this in order to make the difference positive. So abs of an minus an, I just combined it, okay? That's the trait of the series, right? So the positive will just go away, right? It will just be eliminated. But the negatives won't be vanished. They will be remaining, but the double of this, right? So it becomes minus 2 times a3 plus a5. Oh, So what's the difference? The difference is, okay, let me write down here, minus double of and multiplied by sum of negative terms. Okay, so this is our crucial concept, really crucial conclusion. So we're going to use these two. So the first one, if I just summarize again, this is larger. So n plus 1 term itself is larger than adding up 1 to nth term. But how much is it larger? By 2, okay? And the second crucial conclusion was that the difference between the sum of the absolute value of an and just the regular an, the difference was minus 2 times the sum of the negative terms, okay? So these are really important, and let's get started. So we basically need to use the C condition in order to figure out the sign of each terms, right? But first thing you guys should notice is that adding up all these terms are smaller than this itself, okay? So I've just said the difference as well, right? So the difference is 2, right? So adding up 2 to 512 is 1022. So that's the first concept I told you guys. But adding up all the ANs 1 to 10 should be negative number, which means if I assume that the first term, second term, all the way up to the ninth term. Actually, let's just write the numbers as well. I think this is a bit confusing, so first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, and finally the 10th term, okay? So anyway, if I assume that I make everything 1 to 9 term negative, this sum of all of these become negative 1022. But if I make this positive and if I add all of them, it becomes positive, which is 2, right? Minus 1022 plus 1024 is 2, which means it's not negative, it doesn't satisfy the C, right? Which means, in conclusion, this should be negative, okay? This should be negative. Okay, let me just erase the minus signs, okay? So we figured out that the 10th term, the final term, is negative. All right, yeah. So it's like this. So this is negative, and let's say this is all positive. So this is like the opposite case of the previous one. So if I make this negative, and if I just assume that everything is positive to 1 to 9th term, it's 1022, and this is minus 1024. So if you add it, it becomes minus 2. So it's kind of getting closer to this, right? It becomes negative, but we need to make this negative 14, right? Yeah, which means we are going to put some negative symbols to some of the terms. But where do we have to put the negatives? That's actually a bit confusing. So we need to use this second notion. So I've told you guys, so there should be some positive numbers and there should be some negative numbers. It's gonna be mixed up well together, right? But the difference between the sum of the an and the absolute value of the an is this, right? This is the conclusion. Minus 2 times by the sum of negative terms. So look at it. I'm going to manipulate this C. So we know that the last term is negative, which means summing up n is 1 to 9 plus a10. So I just separated the last term. It's going to be negative 14, right? But we know this is negative 1024, so I'm going to put it onto the right-hand side, which means n is 1 to 9 of an becomes plus, right? 1024 minus 14, right? So summing up an 1 to 9th term is 1010. But summing up n is 1 to 9, this time it's going to be the absolute value of an. But we actually know what it is. It's 1022. We already got it. Right? This is 1022. So what I'm going to do is I'm going to find the difference between these two sums, which is going to be summing up n's 1 to 9. Going to subtract abs of an and an. Then what is it? We're just basically subtracting this and this, right? It becomes 12. But I said that 12 has a meaning. It's this, right? So that 12 has a meaning of minus twice times the sum of negative terms. So if I solve this equation, therefore sum of negative terms become negative 6. Oh, so the sum of negative terms should become negative 6. That's really easy to make. Definitely, if you add 2 and 4, it becomes 6. But if you just put the negative signs on it, that becomes negative 6, right? Oh, the conclusion is that 2 and 4 were the negatives, and everything else was just positive numbers, okay? So we got the answer. So the question is asking you to sum of the odd terms, right? The first term, third term, fifth term, seventh term, and ninth term. All right? So therefore, sum of odd, let's say odd th, okay? Terms is minus 2 plus 8 plus 32 plus 128 plus 512. So this is 640. It becomes 672. This is 6. So the final answer for this problem is 678. Nice.